Have you ever wondered how massive apps like Netflix or Spotify can handle millions of people all at once without ever seeming to crash? Well, a lot of the time, the answer comes down to one word: Kubernetes. It really is the secret sauce of the modern internet. And in this explainer, we're going to pull back the curtain and see exactly how it manages to turn total chaos into perfect control.
All right, so to really get Kubernetes, you've got to understand this first. Modern software isn't just one giant program anymore. Nope. Instead, it's broken down into lots of small, independent pieces we call containers. The best way to think about it is like a fleet of ships. Each one has a very specific job, and they're all working together to get the mission done.
Right, but that whole idea, it creates a massive problem. I mean, when you have hundreds or even thousands of these container ships, things get complicated fast. What happens if one of them just sinks? How do they even talk to each other? And what do you do when a huge wave of traffic hits? You absolutely need a captain to steer the fleet. And that right there is the core problem of the modern app. See, without a captain for our fleet of containers, what you get is pure chaos. And listen, these are not just theoretical problems. This is the real world. Think about it. What happens when the container running your shopping cart crashes right in the middle of a Black Friday sale? Or how does your user login container securely find and talk to the database container? These are the kinds of storms that can completely sink an application. And this is where Kubernetes steps onto the stage. If your containers are all the individual musicians in an orchestra, then Kubernetes is the conductor. It's the one making sure every single part works in perfect harmony to create, well, not a symphony, but a perfectly functioning application. So what is it, officially? Kubernetes is a container orchestration system. And that word orchestration is everything. See, it doesn't build your containers, but it directs them. It automates all the really hard parts, getting them running, scaling them up when you get a ton of traffic, and managing them when things inevitably go wrong. You know, this is probably my favorite analogy for it, just because it's so spot on. Just like Windows or Mac OS manages all the programs and hardware on your computer, Kubernetes manages all your application containers and the cloud servers they run on. It's become the foundational layer for running pretty much anything in the cloud today. So how does this whole conductor thing actually work? Well, a Kubernetes setup is called a cluster, and it's basically got two kinds of servers. First up, you have the master node. That's the conductor, the brain of the whole operation. Now, don't worry about all those component names you see there. Just know its job is to make all the decisions. And then you've got the worker nodes. These are the musicians, the actual muscle that runs your app. The master tells the workers what to play, and they play it. Simple as that.
Okay, let's zoom in a little bit here. To really get how Kubernetes manages everything, we have to start with its most fundamental, its smallest building block, something called a pod.
Now, this is a super important distinction, especially if you're coming from the Docker world. In Docker, the smallest thing you ever think about is the container itself, but Kubernetes adds a new layer of abstraction on top. It doesn't actually manage containers directly. Instead, it manages them inside of this thing called a pod. So what is a pod? You can think of it as a little wrapper, a little environment around your container. It gives the container things it needs to live, like its own unique IP address on the network. And yeah, you can technically put multiple containers in one pod, but honestly, 99% of the time, you're going to see a simple one-to-one relationship. One container, one pod. And here is the absolute key to understanding all of this. Pods are treated as completely disposable. They're ephemeral. They can crash, they can be terminated, they can be replaced by Kubernetes at any second. And that means you can never, ever rely on a single pod to be there forever. And this brilliant design choice is what makes the next piece of the puzzle so powerful. So if pods are just these disposable little workers, who was actually in charge of them? Well, that brings us to deployments. If a pod is a worker, a deployment is the manager that oversees them, making sure the right number of workers are always on the job, doing what they're supposed to do. A deployment is your blueprint. It's you telling Kubernetes what you want the world to look like. You don't tell it, hey, go start this one pod. No way. You tell it, my desired state is to have 3 identical copies or replicas of this application pod running at all times. That idea of a desired state is the core concept. And this is where the real magic happens. Because that deployment is constantly watching, it's comparing your desired state, 3 replicas, to the actual state. So, the moment one of those pods crashes and the current state drops to 2, boom, the deployment sees that mismatch, and without any human needing to lift a finger, it instantly spins up a new pod to get things back to the way they should be. That is self-healing in action. It's amazing. So a deployment basically gives you 3 incredible superpowers. You get that self-healing we just saw. You get automated scaling. You want to go from 3 pods to 30, you just change one number. And maybe coolest of all, it handles rolling updates, where it gradually replaces old pods with new ones so your users never, ever see any downtime. Okay, so we've solved the problem of keeping our pods running and healthy, but we've created a new one, right? Remember, they're ephemeral. They come and they go, and every time a new one is born, it gets a brand new IP address. So how does anything reliably find them? That's the job of a service. Let's really make this crystal clear. Imagine your website's front end needs to talk to your user database in the back end. If that database pod suddenly dies and gets replaced, well, it gets a new IP address. Your front end has no idea how to find it anymore. Your application is now completely broken. This is the exact problem that a service is designed to solve.
A service gives you a single, stable IP address and a predictable name that will never, ever change. It sits right in front of your group of ever-changing pods. So when a request comes into the service's permanent address, it just intelligently forwards it to any one of the healthy pods behind it. It's kind of like a permanent P.O. box for an apartment building where the residents are constantly changing.
And you've got a couple of common flavors of these services. The default one is called a cluster IP, and that's for internal communication only, like your application talking to its database. But if you need to talk to the outside world, you use a load balancer. That's what actually exposes your application to the internet so that real users can get to it. So let's put it all together and trace the full journey. A user's request from their browser first hits something called an ingress, which is like a smart traffic cop for your whole cluster. The ingress sends that request to the correct service, our stable address, which then finds a healthy pod to do the actual work. It's a clean, reliable, and incredibly scalable path from the user all the way to your code. All right, so let's just quickly recap the 3 core ideas here. Pods, they're the smallest unit, the little wrappers that run your containers. Deployments, they're the managers, the blueprints that give you self-healing and scaling. And finally, services. They're the stable signposts that let everything find and talk to each other reliably. And that brings us right back to where we started. By combining these simple but incredibly powerful pieces, Kubernetes takes what could be a chaotic, unmanageable fleet of containers and turns it into a perfectly tuned, self-healing, automated orchestra that can run just about any application you can dream of. At the end of the day, Kubernetes is a platform that just gets out of your way and lets you focus on what really matters, building great things. It brings order to the chaos. So the only real question left is, what are you going to build with it?